Hi ladies, in this video we're going to go through these application questions. I'll try to go through them quickly as they are quite long, but remember we're doing these with the calculator, but obviously some stuff will have to be done by hand as well. But try to understand how to do things on your calculator. Don't always rely on doing things by hand, because if you are planning on going into maths methods, you just won't have time to do everything by hand. So you're strongly encouraged to learn how to do things on your calculator as well. All right, let's get started. So question 1, a rectangle has a perimeter of 20 meters. Let x be the length of one side. Find a formula for the area of the rectangle in terms of x, hence find the maximum area A. Okay, so let me just get my pen ready. All right, so we've got a rectangle. There it is. It has a perimeter of 20. And x is the length of one side. Okay, and obviously that's the same over here because it is a rectangle and we don't know what this side is, but we can call that the width if you like. We can call that W. So that means your perimeter is made up of 2x plus 2w. Okay, so the perimeter being the length around the rectangle. So perimeter equals 2x plus 2w. We know the perimeter is 20, so we can let P equal 20. And what we can do is simplify this. So if I take out 2 on this side as a common factor, and then divide both sides by 2, I'm left with, not 20, sorry, 10 equals x plus w. So that means we can say w is equal to 10 minus x. Okay, so what we've done here is I already have the length in terms of x, okay, because the question said let the length equal x, and I have my width in terms of x, so that's just 10 minus x. Okay, so when we work out what x is, the perimeter is going to be 20. The question says find the maximum area. Okay, so now we use the area formula for a rectangle. So area is equal to length times width. So now I just substitute in my value for length and my value for width. So it's going to be x times 10 minus x. Make sure you put brackets in there. You don't have to expand that unless it asks you to, but I'm going to do it just so you can see it's a parabola. So when I expand that, I've got 10x minus x squared. So there's a parabola, and that's your area formula. Now the question says find the maximum area. So I'm going to plot that on a calculator. Okay, so let's just choose graph. Now I've noticed some of you using the scratch pad. I always think these little icons are better. So let's type in our 10x minus x squared. It doesn't matter if you use the factorized version. Okay, so there's our parabola. We can't see this maximum point. So what I need to do is change my window. Okay, so you can zoom out if you like, but I always just prefer to change the window settings. X is fine, I can see X okay, but I can't see my maximum. So I'm going to make that maybe 30. Because we're only looking at this maximum, it doesn't matter about anything else. You know, we can change the scale if we like, but we're just focusing on this maximum point here. Now, if this bothers you, having this fraction, just change it. You can go to doc settings, and instead of having it in exact mode, you can put it in approximate. Oh, sorry. Let's put it in auto. So sometimes you need to go between the two. So sometimes auto, sometimes approximate. Okay. If I redid the graph, that would actually, I think it would change to a decimal, but we're not focusing on that. If I go back to our question, remember it says find the maximum area. So basically what we have on our x-axis is a value of x, which is the length of the rectangle, and your y-axis is actually your area. Okay, so remember if I go back here, area equals 10x minus x squared. So your maximum is here. So on your calculator, go menu, analyze graph, and it's a maximum. So we just go, see how it says in the bottom left-hand corner, lower bound. So we just go to the left and then to the right. And your maximum is when x equals 5, and your maximum area is 25. So if I just, oops, sorry. Let's just go back here. So when x equals 5, oops, my pen doesn't want to work. Come on, pen. Okay, so we found x equals 5 and your area is 25. And when you think about that, that is actually a square. So if you are using all 4 sides, your maximum area will actually always be a square. So find the maximum area. Your maximum area is 25 meters squared, and that's when your length is 5 and your width is 10 minus 5, which is also 5. Okay, so they're your dimensions. All right, so our second question, we've got the efficiency rating E of a particular spark plug when the gap is set at x millimeters is said to be 400 times x minus x squared. Sketch the graph of E against x for x is between 0 and 1. So let's go to the calculator. I'm going to just start a new graph. You don't always have to do this, but I am for this question. Oops. X minus x squared. Oh, what's happening there? All right, so it looks a bit weird at the moment because we can't see our turning point. Now remember the question says we need to do x's between 0 and 1. And I also need to clearly see the graph. So I'm going to go to my window. Okay, let's change our window settings. So I'm going to go from I know it said from 0 to 1, but it's always good on your calculator if you can see the points required, and I'll show you that in a second. And might just leave, or might put that as a negative 10 and cross it out. All right, so there's our graph. So you can see it goes, that's 0 and that's actually 1. But if you needed to see that, remember we could just go to menu, analyze graph 0, and you can just go from the left to the right, and there's your x-intercept, and you can see that crosses at 0, 0. All right, so in this point here, we can just also find by analyzing the graph, maximum, lower bound go to the left, upper bound to the right. So your maximum occurs at 0.5, 100. So you'll need to put that on your graph as well when you sketch it. What values of x give a 0 efficiency rating? So that means when E is equal to 0. So on your calculator, let's go back. Okay, I already can see that is at 0 and 1. Okay, but if you wanted to do it another way, let's just add our page. You can use solve. Okay, so you don't always have to look at the graph. So you just type in your equation and let that equal 0, because your equation is E equals, and you want to know when your efficiency equals 0. So there you can see x equals 0 or x equals 1. All right, what value of x gives the maximum efficiency rating? So again, we go back to the calculator, but we go to the graph screen. Now, if you want to know how to go between your tabs, just press Control and your arrow will take you to the next tab, or you can just click on it. Okay, so here's our maximum. It occurs at x equals 0.5 and the maximum efficiency is 100. But if you wanted to do it on your calculator, sorry, I just had to pause to see if it was actually on there. So we're going to calculus. I think I've actually done this in a previous video. It's a maximum, so we just type in the function maximum, 400 times x minus x to the power of 2, comma x, and you can see it occurs at x equals a half. So then you'll just need to put that value into your equation. So you're going to go 400, just substitute in 0.5, then 0.5 squared, and then you get 100. Or if you prefer, and I've shown you this way as well, actually, you can always copy and paste. So I'm just going to copy the equation or the expression, copy, paste, and then you've also got, if you go control equals sign, given that, x equals 0.5 is another way of doing it. All right, the next question. Use a graph or otherwise to determine the values of x between which the efficiency rating is 70 or more. Okay, so if we go back to our graph, what we can do is we can actually add the line e equals 70. So if I go to tab, type in 70. So remember this F2 is just another way of saying y equals, or in this case, because we're using the variable e, it's e equals. There it is. So we just need to find the intersection of the two graphs at those 2 points. So we go menu, analyze graph intersection. Wants you to go to the lower bound. I think you can only do 1 point at a time. So there's your first point. Okay, so x equals 0.226. And then the other point, we do the same thing. And there it is. Okay, so anything above 0.226 and below 0.774 for question D. Now you could also use solve on your calculator. So you've got two equations, you can just solve if you don't want to look at the graph. All right, question 3. A piece of wire 68 centimeters in length is bent into the shape of a rectangle. If x is the length of the rectangle and a centimeter squared is the area enclosed by the rectangular shape, write down a formula which connects a and x. So this is quite similar to question 1. All right, so I'll get my pen. I didn't really need that equation from before. So I might just cross it out so we know it's not a part of this one. So piece of wire, so that means your perimeter is 68. It's going to be a rectangle. If x is the length of the rectangle, okay, so these two sides are x, and a is the area, so a equals length times width. Write down a formula for which connects a and x. So remember we did this before, so we've got the width. Your perimeter is equal to 2x plus 2w. Perimeter is 68. Now I can go through and divide everything by 2, so then I'm left with 34 equals x plus w. So that means your width is equal to 34 minus x. So your area formula is just going to be your length, x times 34 minus x. And I'm going to leave it like that. I'm not going to expand it. Sketch the graph of a against x for suitable x values. Okay, so let's go back to our calculator. Now I can get rid of everything here. You can either go back to the menu and do some new graphs, or you can just go tab, scroll up and delete what you had. All right, so we've got x times 34 minus x. And I'm thinking if it does that, we need to put in a multiply sign here. Okay, often that will be the thing the calculator can't read. Okay, so if you're multiplying two things and you get an error message, maybe just go back and put your multiplication sign in. All right, so I can't at the moment see my graph, so let's just change the window. Okay, so I'm going to go up to 50 and 300. Let's see how we go with that. All right, so there's your graph. Now, if you're ever thinking, how do I know what to change my window to? You can always think about, well, what your x-intercepts are. So your x-intercepts are when your equation is equal to 0, and your turning point, which is a little bit harder to find, but is halfway between your two x-intercepts, and then you substitute that back in to get that point. Okay, otherwise, sometimes you just you'll get eventually the hang of it, but you will, sometimes you might, when you're beginning, just think, oh, what could it be? All right, and keep increasing it until you find it. Okay, let's go back to the question. Okay, so we've got our equation, we've sketched it, and determine the maximum area. So let's go back. So we go to menu, and I think it actually said, it said your values of x when you graph it. So obviously we're looking at a rectangle, so you can't have negative values of x. So when you sketch your graph, you'd only go from 0 to this x-intercept, which is at 34. Okay, so let's find our maximum now. Maximum, just go to the left of your maximum, and there's your right. So it occurs at x equals 17, and your area is 289. So let's go back. So use your graph to determine the maximum area. The maximum area is at 289 when x is equal to 17. All right, question 4. A piece of wire 80 centimeters long is to be cut into two pieces. One piece is to be bent into a square and the other one into a rectangle 4 times as long as it is wide. All right, I'm just going to pause and delete all this. All right, so I'm going to draw first my square. So first of all, you're looking at your perimeter isn't 80 for each shape, it's for both of them. So the perimeter is equal to 80, but that is your square plus, you can spell square plus your rectangle. Okay, so we've got our square, and I'm just going to draw the rectangle a little bit longer so you can see that it's different. All right, we're going to let x be the length of the side of the square. So that's x by x, and y be the width of the rectangle. So what we have, one piece is bent in the square, the other into a rectangle 4 times as long as it is wide. So if we call our width y, then our length is 4y. All right, now we need to write a formula connecting y and x. Now, what I've got, my perimeter of my square, which is 4 times x, and my perimeter of the rectangle, I'm going to have 2y, the two sides, and then 8y. Okay, so let's, oops, I'm not going to use that. Perimeter is 80. So just 4x plus 10y. And if I take the common factor of all 2, I can do 40 equals 2x plus 5y. All right, my battery is dying on my computer, so I'm just going to make sure I've got enough battery so I can keep going. All right, let a centimeter squared be the sum of the areas of the square and rectangle. So the area, we're going to add them together. So the area of your square is x squared, and the area of your rectangle is y times 4y. So let's just tidy that up a bit. So we're going to have x squared plus 4y squared. Find a formula for a in terms of x. So I've got a formula now in terms of x and y, but I can use this formula from before and substitute it in there for y. So I might do that in a different color just so we don't get mixed up. So if I've got 40 equals 2x plus 5y, let's bring 5y onto its own side, and then I'm left with 40 minus 2x. So y is equal to 40 over 5 and 2x over 5. Okay, it's just to get rid of that coefficient of y. So we're going to have y is equal to 8 minus 2x on 5. And now I can substitute that back into my equation. Let me just change the color. All right, so we've got y here. So it's 8 minus 2x on 5 squared. Now I'm going to leave it in that form because it doesn't actually say to expand it. So I'm going to leave it because sometimes expanding things, we're prone to making errors. All right, so let's put that into the calculator. So grab our calculator. I might actually start a new document just because it's a bit annoying. All those things are already on there. So add graphs. All right, so put in our equation. What is it? X squared plus 4. And 8 minus, oh gosh, I've got to try to remember. Actually, I might write it down. X squared plus 4, 8 minus 2x over 5 squared. Okay. X squared plus 4, 8 minus, oh gosh. X squared plus 4. I'm focusing too much on the wind outside. I don't know whether you can actually hear that. Okay, so then we've got 2x on 5, and then that's all squared. Okay, and I actually can't see that. I should be able to see that. All right, so I'm just going to change my window. So at this point, you're probably thinking, if you did it, it would be like, oh, where is it? So let's just change things a little bit. Okay, I still can't see it. All right, I can feel like I can kind of see something down there. Oh, that might just be the arrow. So what I'm going to do now is just show you. Okay, so and it's not ideal doing this live, but let's add a page. So Control Add Page. We're going to add the calculator. All right, what I've done, so I might go back to the screen, is I've just copied and pasted my expression. So if you highlight it and do Control C, which is copy, you can copy it. So now I can tell my calculator to expand that. Okay, there it is. And you'll probably notice on the answers, it actually put it in expanded form. So that might be a little bit more reassuring for you. Now, if you want to find your x-intercepts, let's just go solve. Let that equal 0, x. Now, that's interesting now. So it's basically saying false. So we don't have any x-intercepts. All right, so we can also find out what the turning point is. So this is a positive parabola, so it means you're going to have a minimum. So I'm going to calculus function minimum, type it in or paste it in, x. So we're going to have a minimum when x equals 320 over 41. Okay, if you want to do that as a decimal, you can just go Control Enter and it'll put it in there for you. Okay, so we've struggled with the graph because we can't, I changed the settings and we couldn't see it. So I know it is the turning point, which is a minimum, is when x equals 7.8. So what I can do now is, can I put my equation back in, control equals, given that, and then I can go back up, x is equal to that, and there's my y coordinate of the turning point. Okay, so we've got the x coordinate, 7.8 of your turning point, and the y coordinate is 156.1. Okay, we'll just round it to 1 decimal place. Okay, so a bit of a difficult question. I'm going to go back to the question. So x is equal to 7.8. Now, if you did want to graph it, sorry, that's why I was doing this. Let's go back. The reason we can't see it is because I think our y-axis is not high enough. So let's just change the y-axis. So menu, window settings. Okay, so let's change our maximum to 200. And your x probably doesn't need to be that big, so I'm going to change it to 20, because remember our turning point occurred at 7.8. Okay, and there it is. All right, so now we can actually see the graph. You can do the minimum here if you like. So analyze graph, minimum, go to the left and to the right, and there you can find your minimum as well. See how it rounds it? So it's probably a good idea to take this value, okay? Otherwise it's giving you a rounded value, which might not always be the best thing to do, reading it from your graph as opposed to this screen. Okay, let's go back to the question. So x is 7.8. Oops, I looked before at the answer, so I knew what my graph would look like. Find the length of both pieces of wire if A is a minimum. So remember your minimum, your minimum was when x equals 7.8. So what you need to do is just come back up here. So your perimeter of your square is 4x. So it's going to be 4 times 7.8. And then your rectangle, your formula was 2y plus 8y from memory. Let's just go back up. Yeah, so 2y that side and then 8y on the other side. So 10y altogether. So we're going to have 10 times y, which is this. 8 minus 2. X is 7.8. Oh gosh, this is a hard question. Okay, so this is probably, yeah, definitely a maths methods question. And then you just put those values into your calculator. So 4 times 7.8, let's go back to the calculator. 4 times, and I'm just going to scroll up to there. And I'm just going to delete the x equals. It's going to give me an answer as a fraction. So let's go control enter. So there it is as a decimal. So that's the length of y used for the square. And now the length of the y used for the rectangle is 10 times 8 minus, all right, I'm going to have to keep scrolling back. So 10 minus, do we have brackets? 8 minus, actually no, it's 10 times, wasn't it? This is why I should probably write things down. And then I'm not scrolling in between. 2 times 7.8. I'm just going to type in 7.8. And that was divided by 5 from memory. Let's just double check. Okay. And then I press equals, and there's your other length. So the square was 31.21 in perimeter, and the rectangle is 48.8. Okay. let's go back to the question. I'll just check how much battery I've got. Well, not much. Okay, question 5, and I might just get rid of all this. Okay, so question 4, a very difficult question, and I assume question 5 is going to be difficult too. A construction firm has won a contract to build cable car pylons at various positions on the side of a mountain. Because of difficulties associated with construction in alpine areas, the construction firm will be paid an extra amount for each pylon, given by the formula blah blah blah, where h is the height in kilometers above sea level. So sketch the graph, comment on possible values of h. All right, I think you can do this on your own. Okay, I'm just reading through. I'll talk you through it, but I'm actually not going to do it. The solution's there for you. Sketch your graph. So you're going to put it on the calculator. I'm just looking at large values here. So you're probably going to have to keep changing your window or look at possible x-intercepts, your turning point, to work out what it's going to look like. Does C have a maximum value? Okay, so have a look at that. I'm just trying to think if it has a maximum value. All right, what is the value of C for the pylon built at an altitude of 2,500? Remember when I did question 2 and I drew the graph of y equals 70, you're going to do the same thing here to find the intersection point. All right, good luck, girls. If you are stuck, just ask for help. Bye.